GraphQL is refining as it goes along, and the patterns that it uses and the architectural styles that fit with it. And unified graph is definitely becoming more popular. So whether you have microservices on the back end with gRPC APIs, or external APIs with REST, or directly to a database, all of those things can be unified in a GraphQL, basically API gateway.
From Toro Cloud, this is the Coding Over Cocktails podcast, a free pool of thoughts and ideas from IT experts, thought leaders, and authors, sharing their insights and advice for individuals architecting solutions for the ever-changing landscape of enterprise tech, digital transformation, and more. Welcome to episode 70 of the Coding Over Cocktails podcast. My name is Kevin Montalvo. With me is Toro Cloud CEO and founder, David Brown. Good day, David.
70. Time flies when you're having fun. I had no idea we're up to 70. Hi, Kevin.
Yeah, too fast. All right, on this edition of Coding Over Cocktails, we're going to have another Tech Smackdown, our third one, putting forth two technologies, concepts, or architectural styles in a friendly sparring match. Today, we're debating between REST versus GraphQL. Which web API architectural style should we use? Let me introduce our guests. On the REST corner, we have a returning guest from a previous episode. He's currently the OpenAPI Lead at Postman and is known as the API Handyman, helping people from executives to developers and everything in between understand what APIs are, why they matter, and how to do them. He authored the book, The Design of Web APIs, which teaches readers how to gather requirements, balance business and technical goals, and how to adopt a consumer-first mindset while teaching effective practices using numerous interesting examples. Joining us today to represent REST is Arnaud Lauret. Hi, Arnaud. Welcome back to the show.
Hi. Happy to be here.
Yeah,
all right.
Great to have you back.
On the other corner, we have the technical lead in open technologies, also at Postman. She focuses on GraphQL as one of the 5 API specifications supported by Postman. Before this, she worked on an API project at Telefonica that exposed backend services, including the billing API, through their global mobile developer program. She has also begun participating in the GraphQL working group, which is responsible for developing and releasing the GraphQL specification. She is the working group co-lead of the Rust compiler contributor program she helped create, called Rust C Contributor New. She is working to bring together and share her knowledge of Rust and GraphQL as more GraphQL tooling is being developed in Rust by Apollo and the Guild. Representing the GraphQL side is Doc Jones. Hi, Doc. Welcome to the show.
Hi, thanks for having me.
All right, on to you, David.
I know. Let's get started with REST. Why don't we start with just a couple of definitions and the origin of these technologies as well, because I think that leads us to some of the use cases for these as well. So REST, what does it do? How did it come about? What's it trying to solve?
So REST is first an architectural style. It's for REST stands for representational state transfer, which means absolutely nothing for most of people. But if we try to make an actually usable description of what REST is, it's an architectural style what was created to actually define the HTTP protocol. That's it. Roy Fielding need that thing to explain what was rationally what was the HTTP protocol, its characteristics, and so on. What is interesting with this style is that you can apply the principles that are defined in REST to any type of API, any type of communication between pieces of software. Nevertheless, some people decided to take the REST names, say, oh, we are building REST APIs, in a sense that they are building REST APIs that take advantage of the HTTP protocol and sometimes follow more or less the constraints of the REST architecture style. So nowadays, when you are talking about a REST API, it's an API that is composed of requests that are get/this and post/that happen to, if it works, return a 200 OK responses with some data. If it does not work, maybe a 400 or whatever. That's the simple definition of what is a REST API. There are numerous debates about being purely REST or not, but basically it's APIs that try to follow the HTTP protocol, and sometimes their creator really think about the principle of REST APIs.
I might dive into that. You were just alluding to there, whether it actually is REST or not. I think that the definition of REST has become more loose over time. So why is that? What is the true definition of a RESTful API as opposed to what we see more often today?
Yeah. So true, and I put quotes around true.
Yeah.
REST API will first follow the HTTP protocol semantic, in a sense that if I see a get/something, I expect that it's a non-dangerous request that will get me some data, and absolutely not delete something. And I've seen people creating pseudo REST APIs that do that, deleting stuff on a GET request. To notify the status of the request, you will use the correct HTTP status code, 200 when it's okay, 400 when the consumer made a mistake. Then you can also take advantage of another constraint of REST, which is cacheability, in the sense that when you return some information, you can provide metadata telling, okay, what we have just give you, you can cache it for 5 minutes, 1 day, or do not cache it. You can then use conditional request, telling, okay, I had those data identified by something. I want to get them updated, and the server can then respond, okay, no, there was no update, so you don't need to retrieve those data again. There is also clear separation between the consumer and the provider of the API, in a sense that the consumer do not need any information about how is implemented the API. And it seems it's a principle that is often neglected, and sometimes too often consumers, especially for internal API in big organizations, want to mingle in how the provider develop its API and so on. But basically, the consumer just have to talk to an interface, and they don't care about what is actually happening behind it. And actually, they don't know if the real system that gave them the answer is the one they are directly talking to. They don't care about that. So there are different constraints, but also we can talk about being discoverable with the hypermedia stuff, in a sense that I can talk with an API and it can tell me what I can do with it. I don't have to rely on documentation.
Yes. Yeah. Okay. So there are some features of the REST API. What, I guess, has made it all pervasive? What has led to its success?
I think that the main, in my opinion, as someone who's written a book about API design and is really an API design geek, it's the uniform interface. In a sense that either I'm using an API from company A or company B, I don't want to quote the usual name, but even if it do not deal with the same topic, for example, an API dealing with telecommunication, an API dealing with banks, if there are true REST APIs, they will work the same because they share the HTTP semantic. So I already know how they work without having to think about it. Also, the HTTP protocol is what has made the web what it is today. It is accepted by a wide range of equipment, from security equipment, routing, whatever. It's easy to implement in any technology. Whatever programming language you will take, there will be the implementation to basically support the HTTP protocol. Now, there are frameworks that allow you to develop REST API more easily, but if you just want to stick with the HTTP protocol, you can do in any programming language. So it's really, I think it's simple to develop. If you do them even not well, you have a uniform interface that make them somehow easy to use, but you can still make terrible REST APIs because there are other concerns. But yeah, I think that's why they were successful in the last, let's say, 2 decades.
Yeah. Okay. Well, Doc, the REST has been incredibly successful, and it is simple. The tooling is robust and all pervasive and covers a lot of programming languages, as Arnaud was just saying. So what caused GraphQL to emerge? What problem was it trying to solve that REST wasn't already solving?
Well, I think probably you and many listeners to this program know that GraphQL hasn't been around as long as REST. It was something that was developed as part of Facebook's effort to create an iOS client. And so as they were trying to create a user experience on a mobile device for the newsfeed, they found issues with having multiple endpoints to be able to deliver the Facebook UI, which has many, many components. And so the other benefit that they got from creating GraphQL was the decoupling of the client from the server. So if you're building RESTful APIs, then there is coordination that has to occur between the server and the client. The client receives, whatever data is available as generally fairly large object that then they have to handle and parse on the client side. But with GraphQL, you can create a query and only request the data that you need for your service or for your UI component. So let me go back and start where Arnold did, which is with a definition. And I will caveat all of this by saying that both GraphQL and I are much newer to this, to the API world than RESTful or Arnold. They've both got a couple of decades on us. I think Arnold's been like telling other people how to build APIs for at least a decade, maybe longer, but he has tremendous expertise and experience. I'm much newer to this. I've been the GraphQL lead at Postman for 2 months. So a lot of what you'll see on my blog is me learning in public. I've been encouraged to do that. And in fact, prodded to do that by Ken Lane, and he's absolutely right about it. The more I do of it, the more value I see in it and why it works. But let's start with GraphQL. GraphQL is a query language and a server-side runtime for APIs that prioritizes giving clients exactly the data that they request. So you and your listeners probably have heard of overfetching as being an issue with REST, and that's what I described earlier, where you get this very large object, whether you need all that data or not, and then the client has to take on the responsibility of parsing it, and GraphQL alleviates some of that. Now, I will say that GraphQL and REST have become incredible technology partners in a number of use cases. It's not unusual to have a variety of either external APIs that are delivering a REST API to then be unified in a GraphQL API. And the purpose of that is to combine various REST APIs in different combinations to create a single service. One example of that would be in the e-commerce space, which this is fairly getting more common, using the backend for front end pattern, where you create an endpoint for a specific application as opposed to a single endpoint for everyone in the public. GraphQL is refining as it goes along, and the patterns that it uses and the architectural styles that fit with it. And unified graph is definitely becoming more popular. So whether you have microservices on the back end with gRPC APIs or external APIs with REST or directly to a database, all of those things can be unified in a GraphQL, basically API gateway. And then again, you can provide various endpoints for whatever service you're trying to service or trying to provide data for. For example, shipping is an activity on the front end that calls various backend services. So inventory, shipping providers, a combination of those various data. What am I trying to say? I'm suddenly flaking on on the word I'm looking for. Anyway, data sources. And you can combine them in various ways. And again, being able to unify them into a GraphQL API gateway has been extremely helpful. And again, you're decoupled from the client. So the client can go ahead and develop their applications and determine what data they need and create queries around that. Without waiting for the development of backend services. So you gain, companies are reporting that they're gaining speed in development and time to market by using GraphQL this way. There are, I think probably the company that has the most responsibility for creating excitement around GraphQL is definitely Netflix. So the very first company outside of Facebook that deployed was Airbnb. But when Netflix basically created subgraphs for all of the microservices, the thousands and thousands and thousands of microservices that they run, to then unify those into a single GraphQL API gateway. They have an entire team that does nothing but manage their schema. Creating subgraphs allowed them to basically allow domain experts within the different service domains to be responsible for creating their own schemas. And so you push, again, it's sort of a decoupling idea where you're pushing that responsibility down to the people who are experts within a certain service area because they developed the microservice. And then the schemas are combined at the API gateway level. And not all instances of using a unified graph result in a public GraphQL API. There are a number of instances where the public API is actually a client of the GraphQL API gateway.
Say that again. Sorry, just to repeat that again for me.
So Twitter is a really good example. Their public API is RESTful, but it is a client of the GraphQL API gateway.
Okay, got it. Look, I mean, we started out by saying REST is simple. It's mimics HTTP protocol. There's lots of tooling and programming languages. Now I feel like I just want to use GraphQL for everything. Like I can get the exact data I need. I don't get the payload. I don't get overloaded with the payload. So I know how does REST deal with these challenges? Does it have an alternative?
And I will also come back to a few things you said, Doug. So regarding decoupling the client and the server, that's one of the constraints of REST. So you have that out of the box. And either you are doing REST, gRPC, GraphQL, or SOAP services, you still have the decoupling between client and server because you can create mocks, you have service definition, and so on. So whatever the type of API, you have that. You can also do query with REST, which are far less advanced than one you can get with GraphQL. But if you want to restrain the amount of data you will get, you can do that. You can use standard formats such as JSON APIs. When you call the REST Twitter API, which is backed by a GraphQL API, but when you call the REST API, you can tell which are the properties you want when you are retrieving your Twitter feed. So it's possible. And also regarding the overfetching, underfetching, whatever, in most of case, I've seen where people come to me to say, hey, we want to use GraphQL because we have some issues. Actually, the problem was not choosing between REST and GraphQL. The problem was designing APIs. And either you do a REST API or a GraphQL API, if you do not work on the design, it will not work. And so sometimes I did that mistake a long time ago when designing a banking API, resulting on the client having, which was a mobile application, having to do many small requests always because the design was wrong. I misidentified the needs from a pure business perspective. And so I fixed that by creating a bigger operation, retrieving more data, but that was making sense from a pure business perspective. So that's really important for people to understand that design is important for all type of API and REST like any other, and GraphQL also. And also talking about simplicity, GraphQL, if you can retrieve exactly the data you want, construct request exactly like what you want, you will get a big bag of data or a small bag of data, which is tailor-made for you and your need, which is cool. Is it exactly what you want? The problem you can have with that is that how you handle cache. So there are tools that help, and correct me if I'm wrong, but there are tools on the client side that help to sort that problem. But in the very beginning of GraphQL, this was a problem. You cannot cache the data, or you can cache them, but you don't know for how long. You also have to, and with REST API, you can easily protect system exposing REST API, putting a gateway and throttling. When you create a GraphQL request, the consumer, if there are no boundaries, they can do anything they want. So they can create very complex requests. Unless, and I've seen, maybe Doc, you have some info about that, but I've seen that now maybe it's embedded in some GraphQL system. You can calculate the complexity of requests to avoid putting the system down behind that.
Okay, Doc, you were shaking your head there. So tell us your thoughts.
Yeah. So I think, I think I have not done a very good job of sharing with my colleague all the things that I've learned about GraphQL, and certainly its modern incarnation.
Right.
Yeah. So caching is common, both on the server and the client side. The other thing that's interesting about GraphQL, the tooling, again, GraphQL has not been around as long as REST. And so the tooling is not, in some cases, not there or immature. This is a fact. That's why most of the tooling that exists at very large implementations like Netflix or Twitter are custom. They've developed their own tooling because in most cases when they started, it just didn't exist. There's a lot of work going on with GraphQL, certainly. GraphQL has been able to adapt and adopt a number of tools from our REST brethren and colleagues. Authorization is a really key one because it's something that is not at all included in the GraphQL spec. There's nothing about authentication or authorization in the spec. And so most implementations and implementers and even tool builders will use OAuth and other authorization tools from the REST world. And there are other things that, that are still sort of at issue that are, constantly in development. But the good thing about the way that GraphQL is constructed, especially on the server side, a schema, I should say, is that you have it's very extensible. So you have a lot of flexibility in terms of creating what are called directives. There are some that come along with the spec that are built in. There is introspection, as Anna alluded to, which allows you to submit a special query that will give you the schema for a given GraphQL, but it's been a best practice for quite a while, unless you're dealing with an internal GraphQL that you really want to disable introspection. You don't want the outside world to be able to get a copy of your schema. And that's a common best practice kind of thing. And so that vulnerability has been addressed. I don't disagree that it was not a problem, in the early days when things were new. But I think there's a number of things that have been addressed. The other thing that I would say is that it's really important to take a look at the fact that most large at scale GraphQL implementations, or even well done ones, rely heavily on REST APIs. So you've got GraphQL being successful because REST is so prevalent and ubiquitous. So you can combine, multiple REST endpoints and wrap them in a graph and, create a service that is easier for the client to consume because it's wrapped in a graph. The other thing that I would like to point out is that a graph in itself, as we combine new data sources and many, many, many more data sources at scale to get, insights, make decisions, all kinds of things, GraphQL has some capability in the fact that it is a graph. So not only do you have the nodes, or what I tend to think of as resources in a RESTful sort of paradigm, but you have context on the edges. So there's important data that exists in the relationships between the nodes, and it's more than just relational database type information. For example, if you look at the most basic implementation of a graph, it would be like online mapping. So you have destinations, and you can create a route between those destinations, but you also living on the edge, have context for things like distance and traffic and weather conditions that are commonly now being reported as part of your, mapping service. There are other examples. I'm not sure how much more of that you want.
Some of that. Is this a case of when we talk about REST versus GraphQL, is it a case of horses for courses, and that there are some natural use cases for GraphQL versus REST? Are there particular use cases which suit GraphQL better than REST? Let's dive into those if there are.
There are. So there was actually an episode of Ken Lane does a video podcast called Breaking Changes. And he did an episode with a gentleman from Oracle Hospitality. And Oracle Hospitality serves, all of these hotel rooms and resorts and that sort of thing. So the reason that they chose GraphQL is because when it comes to doing a reservation, for example, there's a lot of information about a given room that's not within the room object. So there could be, a maintenance issue. There could be, it's available, but in housekeeping. So there's all these kinds of, and I'm not going to represent this, as well as it would be if somebody went and watched that episode of Breaking Changes, which I highly recommend you do, because that gentleman is an expert on this. But there's a lot of state information that lives on the connection between the nodes. And so they found that being able to describe that context on those connections was extremely valuable and was actually helpful in terms of their network usage and the speed of the application. Again, I'm not an expert, so you would have to consult him. But
no, that makes sense. So there was a natural use case for GraphQL. Arnaud, is there what are the natural use cases for REST?
Nowadays, I would say
everything.
As an architect, everything, because there is no silver bullet, never in architecture. But there is the usual answer that you look first, and the other ones. And aujourd'hui, I'm speaking French. And nowadays, REST is the default type for many API because that works well. You have the uniform interface, you know it works. You don't have to think about it. And you can easily define a bounded API that will do specific under a specific subdomain of activity. And so it works pretty well. Most public, if not most, probably 99% of public APIs are REST APIs because everybody knows how to use them, but maybe it will change in the future. We just had, I have GraphQL in my toolbox, and I usually recommend it as Doug described it, in a backend for frontend. Typically, I'm building a mobile application, a web app, and I know I have different APIs to call, to aggregate, and whatever. And using GraphQL can be really useful for that, I think. And so GraphQL will be built probably on other REST APIs.
Sorry, Doc.
Yes, I realized another aspect of GraphQL that's interesting for people who like to use it, and that is the fact that you can specify error handling within the schema. And so that's not an external thing. Errors are handled automatically for every query and every mutation.
I'd like to throw
Speaking of mutation, the one thing I really like the query capacity of GraphQL. It's really amazing. But when it comes to modifying data, I don't like that because I lose the uniform interface. Because with the REST API, you have your address resource, you get your address, and if you want to modify it, you just use the same endpoint, change the HTTP method, and it works. With GraphQL, we come back to, when it comes to modification, we come back to the RPC world, and so you have to define your functions. Unless I'm mistaken, there are no, I think that Netflix and Twitter, if they want to provide a mutation that allows to update something, they can name it, update this, or save that. And so you cannot guess how it works by just looking at it. Hopefully you have a schema, but it's just, I'm a bit, let's say, complicated. I like to put things in box to be able to go from one thing to another. And in GraphQL, the query is, in my opinion, too much separated from the modification. But that's probably a problem only for me and most people, especially people who develop mobile application and website, don't care about that. But for a public API, when you need to guess how things work quickly and easily.
You start off by saying REST is an architectural style. So I'd like to throw a spanner in the works to bring the show to a conclusion. Is, say, the emergence and dominance that we're seeing with event-based processing and pub-sub architectures, is an API format like async API going to come along and eat both your breakfasts?
I'm going to start on this one because this is my favorite. This is my favorite thing is when somebody says a technology is going to replace another technology. In my experience in this industry, that never happens ever. So there will be REST will continue, GraphQL will continue, and async API will take its place. And there will be, because we have these great fit for purpose technologies, there will be specialization, and people will, after more experience with GraphQL, it will find its place and its role within these new complex systems that we're faced with going forward, and the increasing amount of data that is required to be handled by everything. And async API does a beautiful job of focusing on messages as opposed to the kinds of things that GraphQL and OpenAPI deal with. So the answer, I am completely convinced and strongly believe, is yes and. So REST and GraphQL and async API.
Yeah, totally agree with that. And there is no silver bullet. And it's really important that people stop to be fanboys. And I purposely say fanboys because, let's be honest, men in technology can be a bit dense sometimes. But it's really, first, what is the problem you are trying to solve? Work on that, the technical problem with business perspective, define your problem, what you want to do, and then choose the right technology that will work in the context of your problem and in the context of your organization. Because if you want to introduce a completely new technology that nobody can deal with inside your organization, it's a huge problem. And if you choose the wrong technology, it's a huge problem. You will just create new problems instead of solving them.
I can't think of a better point to end the program on. Arnaud and Doc, thank you very much for joining us today. I think that was really informative to differentiate between the two technologies. It was great to have you on the show today.
Thank you for inviting us.
Hey listeners, thank you for joining us in this round of cocktails. Please like and subscribe to check out other episodes of this podcast series. We're also available on your favorite podcast platforms, or you can simply listen in at torocloud.com, where you'll find full episode transcripts and show notes. On behalf of the team here at Toro Cloud, thank you very much for listening to us today. This has been Kevin Montalvo for Coding Over Cocktails. Cheers!